Hello, guys. Good morning. Can you hear me? Am I audible?
Good morning, sir.
Very good morning, guys. Very good morning. Very good morning.
Sir.
Very good morning. How are you all? Hi, Rajesh, Nagata, David, Miracle. Everyone, good morning. Good morning. Good morning, guys. Good morning. I hope you are all good. Okay. So today we will have chapter 28. And yesterday we were doing that thing. What thing we were doing? Carbon and its compound. Today my network is not working. Let's see. It's working very good. So we did yesterday. Okay. Here a diamond. Okay. So we'll yesterday we learned about the allotropes. Okay. Allotropes we learn that diamond and graphite both are made up of same carbon atom, but both have different properties. Yes or no, David? Turn on your camera. It's okay. You are the single boy. So, what was I was saying that diamond and graphite both are made up of carbon, but because of different pressure and different temperature when they were made, they have different properties. Like diamond is the hardest, graphite is the flexible. It's not like hard as compared to the this thing. Second difference, Ira. What is the second difference? What is the second difference?
Uh, the graphite is flexible and the diamond is hard.
That I told.
Oh.
You're just repeating my sentence. Very well.
Okay, wait. Carbon,
Second.
all four electrons are bonded, and
Uh,
graphite one is loose, so it can electricity can pass, and in diamond it
very good.
cannot pass.
Very good. Very good. Miracle, you didn't understand anything? Yes, Miracle. Ask me.
No, sir, I understood.
No, sir, you didn't understand. What are you saying? No, sir. Okay. Sorry.
Yes, sir, I
Uh,
understood.
okay. So we'll read this, and I request, like David today he wore specs, so he can see clearly. Then, David, please read this.
Sir, these don't have a number, sir.
You don't have number, so it
No,
is for fashion.
no, it's only for like the computer if I'm using it.
Ah, that UV one, UV protection.
Yes.
Okay. Now,
So
now read this.
diamonds, right?
Yeah.
Diamonds are formed inside the earth under conditions of high temperature, about 1500 degrees Celsius, and high pressure, about 70,000 atmospheres. South Africa is the leading producer of natural diamonds. In India, diamonds are found in Panna and Madhya Pradesh, in Vajrakarur, and in Andhra Pradesh.
Hmm.
In a diamond crystal, each carbon atom is linked to four other carbon atoms by
Hmm.
covalent bonds in a tetrahedral fashion. This
Tetrahedral.
results tetrahedral fashion. This
Hedral. Hedral.
results hedral. Okay. This results in a three-dimensional arrangement as shown in Figure 28.1. Uh, the three-dimensional network of covalently bonded carbon atoms provides a rigid structure to diamonds.
So,
This
so question they can ask you question why the diamond are the hardest substance of the universe because of the 3D shape, and that 3D shape covalent bond of carbon provides them rigid structure. Okay, that's why they are the hardest substance. Got it? So it can come in 2 marks questions. So everyone, please mark it in your respective PDF or respective book that diamonds are rigid because of their 3D structure. Yes, yes, read, Mr.
This
David.
rigidity makes diamonds a very hard substance. It is, in fact, the hardest natural substance known. The only other substance harder than diamond is silicon carbide, which is also known as carborandum. But note that diamond is a natural substance, whereas carborandum is a synthetic one.
Yeah. So diamond is silicon carbide, which is also known as carborundum. So means carborundum is synthetic one. Okay. And the diamond is a natural occurring one. Got it? No, you didn't understand. Yes? Yes. Yeah. Please, Mr. David.
Diamonds are basically colorless, however, some impurities impart color to them. The density of a diamond is high. It has a value of 33.151 grams per centimeter cube. The melting point of diamond in vacuum is also very high, that is 3500 degrees Celsius, because a large amount of heat energy is required to break the three-dimensional network of covalent bonds.
So they can ask you this thing also, that why the melting and boiling point of a diamond is very high. It is the same reason, because of the 3D structure which give them rigid no 3D dimension network of covalent bonding, which give them rigid structure. Hence, their melting and boiling point are very high, like a Burj Khalifa. Got it?
Since all four electrons are covalently bonded, there are no free electrons in diamond. Hence, it does not conduct electricity. But diamond is a good conductor of heat. Its thermal conductivity is 5 times that of copper. Thus, it can easily dissipate the heat energy released by friction when it is used as an abrasive.
So means if you will rub a diamond little bit, then you will say, oh my god, it's very hot, I can make egg on it. So diamond is very good conductor of heat as compared to the electricity. Now why diamond doesn't conduct electricity? The same reason. No free electron, the flow of electron won't be there, hence there won't be any conduction of electricity. Yes, Agatha.
Sir, in the exam, can we write 3D?
Yeah, 3D, and then in bracket you write 3-dimensional.
Okay.
Okay. No, you didn't send it.
Understood. Thank you.
Good. Yes, Miracle.
No, nothing. Just
Nothing.
nothing.
Okay. So yeah. Yes, Mr. David.
Because of its above mentioned properties, diamond has the following uses. It is used in cutting and grinding of other hard materials. It is also employed in instruments used for cutting of glass and drilling of rocks. It is used in jewelry. Beautiful ornaments are made with diamonds. The high refractive index of diamond, 2.5, makes it very brilliant when it is properly cut and polished.
Correct. So these are the all uses of diamond. It is used for cutting and grinding the hard material. It is also employed in instrument cutting glass. So we can read it. Now there are synthetic diamond. We'll read this also. Mr. David.
Synthetic diamonds. Because of their importance, diamonds worth millions of dollars are synthesized. In the 1950s, Diamonds were synthesized by the scientists at General Electric in New York. They heated graphite to 1500 degrees Celsius in the presence of metal such as nickel and iron under a pressure of 50,000 to 65,000 atmospheres. Most of the diamonds so produced are used as abrasives and for making diamond coated cutting tools used for drilling. Most synthetic diamonds lack the size and clarity of natural diamonds and are generally not used in jewelry. Gem quality diamonds can be produced but they are costly.
Yeah. So they are cost as like diamond only, so nobody made them. Now we'll read about the graphite. So yes, so
Sir,
I request yes, Agatha, please.
so the diamonds that we are using in the diamonds in the jewelry, diamonds used in jewelry are always natural, right?
No,
Yeah.
not
Means
always. You get
like
you get lab
hmm.
grown diamonds also in
So
jewelry.
for example, if like a bangle, if it is as diamond, and if it is only 250 rupees, then you will not have the real diamond. And if it is 2 lakh or 22 lakh 50,000 rupees, then it is a real diamond. So the rate will be also better. So 250, you will go to the market and say, Mama, 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 I bought a bangle of 250 and it has a lot of diamond. We will sell it. So it has no worth because it's not a diamond. Okay. Yeah. So this is the thing. Yeah. So I request Ira, please read this.
Okay, graphite. In contrast to diamond, graphite is soft, black, and slippery solid. It has a metallic luster. It is also a good conductor of electricity and heat. Both graphite and diamond contain only carbon atoms. Then why do they exhibit such different properties? We can find an answer to this question if we look at the structure of graphite as given below in figure point 28.2.
Hmm.
You can
So
see
you can see that. Yeah, you read.
You can see that in contrast to diamond, which has three-dimensional tetrahedral arrangement of carbon atoms, graphite contains layers of carbon atoms. In each layer, a particle carbon atom is linked to three other carbon atoms in a sigmoid planar arrangement with a bond angle of 120 degrees. Thus, three electrons of carbon are covalently bonded to the other three carbon atoms. The fourth electron, which does not participate in bonding, is free. These electrons of various carbon atoms are free to move along between the layers and hence are able to conduct electricity.
Yeah. So, as I told you, only three carbons are bonded and one is free. And that free electron helps us in the conduction of the electricity. Free electricity. Perfect. Yeah.
Okay, the bonding between these layers of carbon atoms is weak. Hence, these layers can slide one over the other. This property makes graphite a good solid lubricant. The
है क्या?
density of graphite
Yeah,
is
yeah.
less than that of diamond. It has a value of 2.2 G centimeter minus 3. The melting
Hmm.
point of graphite in vacuum is about 3700 degrees Celsius. Graphite can
Hmm.
be converted to diamond by applying very higher atmospheric pressure and temperature.
Perfect. So everyone, you are getting this, no? We did this yesterday.
Sir,
Do you have any problem? Yes, Agatha, please.
well, covalent bonds. Okay, I have a question. Graphite and
Please.
diamond are both form covalent bonds.
Perfect.
Then how can a diamond be more stronger?
What is the answer of that? Because of its
3D shape?
3D shape, and all four carbons are bonded in such a way that it makes a 3D rigid structure. But in graphite, because one electron is not there, so this means that carbon is just like we have two things. First is a thing which is stick by the Fevistick, okay, and the thing which is stick by the M-seal. You know M-seal or the Feviquick. You know Feviquick. In two
Maybe
seconds
what?
it will stick. Feviquick.
No.
You don't know Fevicol. You know Fevicol.
So I know enough Feviquick.
You know Fevicol, that white color. Agatha, how will you stick the
No.
paper? How will you stick the paper?
Oh, with
Glue,
glue.
Agatha.
Yeah, that glue. So we have one stick that like lipstick. That stick used to come. You know that thing. Okay,
Yeah.
so that stick never stick the paper. Like for just some for some temporary thing, you can use that. But glue is permanent. Okay, so in the same way, the graphite structure is like that. Only three carbon is attached to it. One is free, hence it doesn't make rigid structure. I told. Did you understand? No, you didn't understand.
I understood.
Yeah. Now we have
So,
another
sir,
buck.
so which is stronger,
Yes, please.
covalent bonds? So are ionic bonds stronger or covalent bonds stronger?
Ionic.
Okay.
Ionic bond is stronger than covalent bond because I told you, if Ira will say, okay, this makeup kit is yours, so you will become a very good friend. If Ira will say, okay, we'll share this, so yeah, okay, yeah, normal thing, normal one. So this is that thing, giving whole thing, then making a very good friend. Yes, Jeshram.
Sir, in covalent bonding, it's connected. The atoms are connected. So wouldn't holding hands with someone be a bit stronger than standing apart from them?
Say it again. Say it again. Say it again.
Wouldn't holding hands with someone be a bit stronger than like physically is more stronger together than standing apart from them? It's a doubt that I've always had.
Holding hands. Holding hands like they're just holding hands.
But like if one is
Mm.
going to fall off the cliff, the other can hold on to the, to safety.
Yeah, but I mean,
I don't think
like
that works with chemistry.
friend and friend. Like for example, Agatha and Ira they met, so they will hold hands and they will go to the for the park and everything. But if you are in family, okay, then you always hold your hand. Like you are going, you are eating everyone. No, no. So family is a bond in which, like, it's like ionic bond. So I hope you get it. Okay, next is Buckminster fluorine. Buckminster fluorine is also the form of carbon only, but it's in the shape of football. Okay, Messi, Ronaldo. That is the thing. Okay, so Buckminster fluorine is the shape in which carbon is arranged in a football-like structure. Which structure? Football-like structure. So it is a football-like structure. So I request Agatha, please read this.
Fluorines. Fluorines were discovered in 1985 by Robert F. Kerr, Harold W. Croto, and Richard E. Smalley. It's a Smalley.
Yeah, Smally.
Smalley.
Smelly. It's smelly. Richard is smelly. Yeah. They
David awarded the Nobel Prize in Chemistry in 1996 for this discovery. Fluorescents have closed structures like a football. A typical fluorine, named as Buckminster
Buckminster fluorine. Yeah. So it is made up of 60 carbons. So in this paragraph, they will simply ask in the MCQ that structure which is it's a football like structure and have 60 carbon in it. So what is this diamond graphite Buckminster fluorine or co? So it's Buckminster fluorine or fluorine. Okay, so they can uh, ask you in the MCQ time. Yeah, please.
Fluorines are formed when vaporized. carbon condenses in an atmosphere of an inert gas. The discovery of fluorescence has opened up a new field in chemistry. Fluorescents of various other sizes are being synthesized, and their properties and uses are being studied. New materials which contain metals enclosed in the fluorines are being synthesized. It is hoped that these materials would find use as superconducting materials, new catalysts, polymers, etc. In addition to the above three allotrophic forms, carbon also exists in three microcrystalline or amorphous forms of graphite. They are charcoal, coke, and carbon black.
Yeah, charcoal, coal, carbon, and black. So, Miracle, please read this charcoal. Yes, Miracle.
Yeah. Mm, Charcoal is formed when wood is heated strongly in the absence of air. It has a large surface area. Activated charcoal is a um,
Pulverized.
what's it? Pulverized form whose surface has been made free from any absorbed materials by heating with
Adsorbed.
steam. Materials by heating with steam. It is widely used for absorbing colored impurities and bad odors from water and other substances. Coke is an impure form of carbon. It is formed when coke is strongly heated in the absence of air. It is used as a reducing agent in metallurgy.
So, charcoal is made up of wood, okay, in the absence of air, okay, and coke is coal when heated in the absence of air. So, they both are different things. You guys have to remember this, okay. So, now I will give you 3 minutes, okay, we'll 3 minutes, not break, but to read, yeah, the chapter till here. And if you have any problem regarding this, so I can take doubt. Otherwise, we'll move forward.
So,
3 minutes.
such charcoal
Hmm.
is made by absence of air, isn't it?
Yeah, when wood is burned in the absence of air.
Yeah, yeah.
Don't go anywhere. Just read the chapter. I'm giving you 3 minutes. Okay, read the chapter. If you have any problem, ask me. Okay, otherwise we'll move forward.
Sir, the three allotrophic forms of carbon is fluorines, diamond, and graphite.
Diamond. Yeah.
Okay.
Sir,
Yeah.
have they mentioned carbon black in the section? I mean, in the book?
Say. Sorry.
No, in the three names that they've given, they say charcoal, coke, and carbon black. They've written about charcoal and coke, but I can't see carbon black anymore.
Yeah. Let me check if the page is there or not.
Carbon black is under that activity. Do you have a PDF or a textbook, Chesro?
I got it, sir. Thank you.
Sir, Charcoal, coke, and carbon black are three forms of graphite.
Yeah, graphite crystalline.
So it says charcoal is formed when wood is heated in absence of air. Is that also calcination? Like that day you said when there was
No,
no
no.
roasting.
Calcination is metal ore,
Okay.
not anything.
Okay.
Not anything. Metal ore when heated in the absence of air. That is called
Only
as.
for ore. Okay.
It's only for ore.
Okay, sir.
Third,
Yeah.
does charcoal help in absorbing material?
Its charcoal helps in absorbing material.
Yeah.
Char- Charcoal helps in absorbing material. Yes. Charcoal helps it absorb basically the order or impurity in the when you are in jungle and when you are not able to find how to pure the water, the river water. So it's like they burn the wood, and when they burn the wood, they will get coal out of it. Okay, that coal they use it as for the purification because it kills the germs and also everything.
Isn't charcoal, coke, and carbon black a form of coal?
Yeah, they all are cousins, brothers and sisters.
But isn't coal made after years, like how they say, years of being under the soil with in the absence of air?
That is coal. That is coal. Okay. Now charcoal is when I burn the wood in the absence of air. So that they have different chemical properties. Like the coal will have more fuel as compared to charcoal, but they all are like brothers and sisters. As I told you, they have similar type of thing. Okay. Now we will learn this. Any problem till now? No problem? Okay. Now we will learn carbon, compounds of carbon. Compound of carbon. So we will learn this. See, organic compounds, earlier organic were defined as those compounds which are originated from living beings, but now it is possible to synthesize. So organic, first of all, we'll learn about the organic compound. Everyone, please pay attention. Now, organic compound is the compound that is like they are uh, originated from the living beings. For example, glucose. We produce glucose when we eat food. When we digest it, the glycogen is formed, and that glycogen is basically the organic compound. So any compound that is that can be derived from the human beings is called as organic compound. Human beings or animals or plants, anything. Okay, any living thing. Okay. Now these the compounds of carbon which are not organic compounds are called as inorganic compound. Most of the inorganic compounds are obtained from various minerals. For example, limestone, marble, dolomite contain carbon carbonates. Okay, these all are inorganic compound. Like we will not produce marble, and no human being or no living being will produce marble. That they are vomiting and marble is coming. The marble stone is coming. It's not like that. Okay. Organic compounds are obtained from natural resources such as plants, animals, coal, and petroleum. That plants and animals are the so why coal and petroleum are considered as organic compound, because when plants die or when animals die, so the sand will cover them and they will go down to the earth. And when they go to the down to the earth, their bones or their cell wall or the body structure, it will convert it slowly into the coal, which is as a fossil fuel. So
So
these
fossil
all,
fuels are organic compounds.
yes, fossil fuels are organic compound. Most of the fossil fuels.
So
Okay,
isn't limestone, marble, and dolomite contain why are these inorganic compounds since they are not well natural?
they are not related to human any living being.
Oh, so organic compounds should be related to at least some living being.
Yeah, we can say like that. Till now,
So,
11th class, everything will be changed. Yeah.
any inorganic this compounds like now you said like a coal is an organic compound, right? Fossil fuel.
Yeah.
Are there any inorganic fossil fuels?
Are there any inorganic fossil fuels? See, right now in Jammu and Kashmir, it's true or not, I don't know. Lithium is found, which is a mineral, and which will also use as a fuel for uh, for making no, not lithium. It was like mm, what was that? I forgot it. Some source of energy. Sorry, radioactive metal. The radioactive metal.
So uranium.
Okay, yeah, uranium. Okay, it's not considered as a organic compound. It's a
But
fuel
it's a
for the
natural.
nuclear power plant. Is it natural? It is also natural, but it is not considered as an organic compound. Okay. Yeah. So coal gives us benzene, phenol, naphthalene, petrol source. So these all are the difference between the organic and inorganic compounds. You guys read it and then we'll do it. Now, the first property. Now we will read the property of the chemical properties of a carbon. So everyone, now fold your hands and listen to me. Okay, chemical properties of a carbon. Now, what are the chemical properties of carbon? That first is oxidation No, before that, I guess we have to start the IUPAC naming. But let me check. Do you guys have IUPAC naming or not? Give me a second. If IUPAC naming is there, then I will start the IUPAC naming first. Open, bro. Yeah, naming is there. So, guys, will not do this. My bad. Because in your this thing is not good. First, we will go to the next part for this, which is called as IUPAC naming. This is another topic. Like in your book, it's not like it's mixed, but it's a different topic called as IUPAC naming. So put a heading IUPAC naming. Put a heading IUPAC naming. We'll read this first. Okay, then we will do this. IUPAC naming. Yeah, IUPAC names. IUPAC is International International International. I forgot the name.
Union?
Maybe International Union. Yes, correct. International Union of Practical and Applied Chemistry. Applied Chemistry.
So
Now,
I think it's pure and applied chemistry.
pure and not so practical. Pure, oh, pure. I guess it was practical. Okay, now everyone please pay attention. Now this is the different thing. Okay, I told you that carbon make covalent bond. Okay, so if carbon make covalent bond, so we will understand it like this: how to name a carbon compound. How to name a carbon compound. Okay, see, if I will make a question like this now, everyone please pay attention. Fold your hands because you will not get anything otherwise. Okay. Now, if I will draw a carbon compound like this, C, 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 C. So are these carbons all are balanced? No, not at all. Why? Because I told you each carbon should has 4 lines with it. Like this carbon has how many lines? Only 1 line. 3 lines are missing. So if I will not draw the rest 3 lines, it means that the rest 3 lines, hydrogen is attached to it. Like this. If I will not draw. Like in the second carbon, Miraculin, in this, how many lines are missing in for this carbon? For this carbon, like each carbon should has 4 lines, na? So this carbon has how many lines? 1 and 2. Rest 2 are missing. So if rest 2 are missing, then we will write it like this. Okay? Did you understand? Miraculin. In the next carbon, how many hydrogen will join?
1 minute, sir. I can't see that.
How is this all being balanced? I mean, carbon needs at least a valence of 4, right?
Yeah. Can you see this now, Miraculin? No.
Yeah, can you repeat that question?
I'm saying that like each carbon should has 4 lines with it. Now this third carbon, it has only 2 lines. 2 lines are missing. What does this mean? This means that 2 hydrogen bonds are bonded with it like this. Got it?
Okay, sir.
Okay. Uh, in this also 2 is left, so I will write 2. So each carbon should has 4 lines, denoting all 4 electrons are bonds. Did you understand? So
Yeah, sir.
okay. So now everyone please pay attention. Now if a compound is there in which only carbon and hydrogen are joined, it is called as hydrocarbon. This is called as what? Hydro
Hydrocarbon.
hydrocarbon. Hydrocarbon means a bond of hydrogen and carbon. Did you understand? A bond of hydrogen and carbon is called as hydrocarbon. Okay. Now, hydrocarbons are of 2 types. Hydrocarbon are of 2 types. First is saturated hydrocarbon. I'm writing HC for the hydrocarbon. Okay. And the second one is unsaturated unsaturated hydrocarbon. Did you understand, guys? Okay. Hydrocarbon is only the bond of carbon and hydrogen, and hydrocarbons are of 2 types: saturated hydrocarbon and unsaturated hydrocarbon. Okay. Now, this is a new
So,
concept. Yeah.
I have a question like, what is saturated
Yeah.
hydrocarbon?
We will discuss it. We will discuss it. No problem in it. Okay. Saturated hydrocarbon and unsaturated hydrocarbon. We have 2 types of hydrocarbons are there: saturated and unsaturated. Now, saturated hydrocarbon is the hydrocarbon in which the carbon and carbon has only a single bond. Okay. Now, everyone, please pay attention. David, don't write anything. Okay. If if carbon, if in a compound, if in a compound, carbon and carbon has single bond. If it has single bond, then they are called saturated hydrocarbon. Now, everyone, please pay attention. What does this mean? This means that, for example, this one. Now, every carbon and like I'm not saying any other thing. Not carbon, hydrogen, nor carbon, oxygen, or no. I am only saying carbon and carbon. Like this carbon and this carbon has only 1 line, denoting single bond. This carbon also has 1 line, denoting single bond, single bond, single bond, single. So each compound, in each carbon and carbon bond is single bond. Hence, it is called a saturated hydrocarbon. Did you understand? Yes or no?
So,
Saturated.
yeah, so if two carbons has a single bond, then they are called saturated hydrocarbon.
Not 2 carbons. Oh, not 2 carbons. In a compound. In a compound, like if there are 100 carbons are there. If all 100 carbons have only single bond. This is the thing. If 2 carbon, like if out of 100, if garam bahut garam hai mera. मतलब garam. So if two, like out of 100, if one carbon and carbon has double or triple bond, means 2 or 3 lines between them, then they are not called as saturated hydrocarbon. Okay. I'm repeating again. Listen to it carefully. Like 100 carbon chain is there. Okay. 2 carbons, like 98 has single bond, but 2 carbon has double bond between them, like that. 2 lines are there. They are not saturated hydrocarbon. They are unsaturated hydrocarbon. Got it? Okay. Yeah.
So, sir,
Hmm.
if only two carbons make a bond, it's called saturated HC. But if more than two carbons make a bond, then it's called unsaturated
No, no,
HC.
no, 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 no. You're getting wrong. If like for example in a compound four carbon is there, four carbon is there. So I will take one example. For example, there are four carbons are there. One, two, three, four. And all the carbon has single bond. Single bond means single line between them. They are called as saturated hydrocarbon. But if one carbon, like if I will make double bond between them, they are not saturated hydrocarbon.
Okay, now I got it. Now I got it.
Okay. Okay. Now listen, listen, guys. This is now important thing which we are going. Saturated. Uh-huh. Hmm. Yeah. Saturated hydrocarbon are also called as alkanes. Agatha, don't write alkanes. Alkanes. Okay. Alkanes or olefins or paraffins. 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 Give me a second. Paraffins. Paraffins. Alkanes or paraffins. Saturated hydrocarbon is also called as alkanes or paraffins. Okay. They are also called as single bonded hydrocarbon. They are also called as single bonded hydrocarbon. Who? Saturated hydrocarbon. They are also called as alkenes or paraffins or single bonded hydrocarbon. Now we have to focus on the word this thing. Uh-huh. We have to focus this word called as क्या हो गया इसको? We have to focus the word name as alkanes. Alkane. Or I will write alkane. Why I am telling it to you guys, you have to focus it on alkane because because any name of a carbon compound we will know it by the this thing. How? See everyone please pay attention. Everyone please pay attention. If if a name is there, butane. If a name is there, for example, butane, we have to focus this ANE. ANE. So if any name is there in which ANE is there, if for example, if I will write butane, so like in the last ANE is coming, in the last what is coming? ANE. It means that the compound, the butane compound, all carbon atoms will have single bond. Did you understand? Now, if I will say pentane, ANE, pentane. Now in the last what is coming? ANE. So in this compound, pentane, all the carbon will have single bond. That is the meaning. Got it? Yes or no? Yes, David.
So, is butane a gas?
Butane, no, it's not a gas.
No.
No. Okay. Alkane. Everyone, please pay attention. Are you getting my point or not? I will give
Okay.
time to write.
Okay, so A and E like mm,
AN denotes that the compound is single bonded. That thing.
so A and E. So if a compound has A and E in the end, it denotes if the compound is single bonded or saturated.
Yeah, yeah. Every carbon atom is single bonded. That is the meaning.
Or the single bonded means saturated, right?
Yeah. Okay. Now everyone, please pay attention. To know why my today's pen is not working.
So,
Yeah.
sir, any compound with A and E in the end means they're single bonded.
Correct. If I will write hexane. So A and E is there. So it means that everyone will have single bond. Got it? Now a compound is alkane or not. There is a formula for that. It is called as CnH2n plus 2. If a formula R is in this form, then it will be alkane formula. And if it is alkane formula, then it is a saturated hydrocarbon. We'll take one example, then I believe you will get it. For example, if I will write a compound name C4H10. C4H10. Okay. Now N is basically 4. So if I will write in this formula C4H2N plus 2. So it means that H2 into 4 plus 2. H2 into 4 plus 2 will become C4H8 plus 2 C4H10. It is satisfying this formula. Hence, this compound is alkane formula. In alkane formula, the carbon atoms double. If you will do double the carbon atoms, which is 8 plus 2. See, there's a trick to find the compound is alkane or not. Carbon atoms, number of carbon atoms, double plus 2. Like 4 double 8 plus 2, 10. It's a what? Alkane. If I will write C4H8, is it in the form of double plus 2?
How
It is
can
only
it be
double.
the form of double plus 2?
We have this formula. I will teach you. No problem with that. First, listen to this. That if only double is there, C4H8 double, then it is not alkane. So hence it is not alkane. Double plus should be there. Okay. Miracle, tell me, is this alkane or not?
No.
It is
No.
alkane, right?
It is alkane. Miracle, listen. 3 is there carbon atom. Do double.
We more like multiply like this, Miracle. We can multiply 2 times 3 and that will be 6. And we add 6 and 2 and that will be 8.
Yeah, Miracle. See, how many carbon atoms are there? 3 is there. Can you see this? And if you will do double of it, 6. It will be 6.
Yeah.
And plus 2, which will be 8. So we have 8 hydrogen atoms.
Okay.
So it means that it is alkane. Got it? For one more example, I will take. One more example I will take. If I will write C2H6, Miracle, tell me. Now 2 is this carbon atom.
Yeah, it's alkane.
It's alkane. Why? Because 2 into 2 is 4, plus 2 is 6. Hence it is satisfying. It's a alkane. So this is an alkane. David, tell me.
Yes, it's alkane.
Why? 7 into
7
2,
into 2,
14.
14 plus 2, 16.
It's an alkane. Ira, tell me this.
So it's not alkane.
Why? Because it is only double. It's only double. So this is how you will get the trick. Now I will draw the structure also. Like if I will draw this one, C4, C. Jashwan, are you getting it now? C4H10. Jashwan, tell me, is it a alkane or not?
It's an alkene, sir.
So now we have to draw the structure also. Now, how many carbon atoms are there? How many carbon atoms are there? 4. So we have to write 4 carbon atoms like 1, 2, 3, 4. And because it's an alkane, so every carbon will have single bond between them. Got it, everyone? Now in the starting, I was saying that each carbon should have 4 lines. Each carbon should have 4 lines. Now if I will number this, this is 1, this is 2, this is 3, and this is 4. So in first carbon, how many lines are there? Only 1 lines are there. Miracle, are you getting it?
Yeah, sir. Got
So
it.
how many lines needed in the first carbon? Only 1 lines are there. How many lines are
Yeah.
needed? Tell me. Like I told you in the starting that each carbon should have 4 lines with them. How many
Yeah.
lines? 4 lines
4.
with them. Now in the first carbon, how many lines are there? Only 1 line is there. This one.
Yeah.
So how many needed? 3 more lines are needed. So I will make
Yes.
3 lines. 1, 2, and 3.
Yeah.
Now Agatha, in the second carbon, how many lines are there?
2.
And how many more needed?
Well, just 2 more.
2 more. 1 and 2. Like this. Got it? Ira,
Yeah, I
in the
got it.
third carbon, how many lines are there?
There are 2, sir. You need 2 more.
2 more. 1 and 2. Just one. In the last carbon,
There's 1 line. We need 3 more lines.
1, 2, 3. Now each line just write H in it. 1, 2, 3, 4, 5, 6, 7, 8. Like this. Now we will count the number of carbon and number of hydrogen. Okay. So 1, 2, 3, 4. 4 carbon is there. And how many hydrogen are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen is there. And it's an alkane compound. We can conclude this also. Got it, everyone? No.
Are alkane metal, I mean, are alkane compounds also alkane metals?
No, metals, they are not metals. Metals is a different concept, no? This is carbon. Carbons are not metal, they are non-metals. So if the question will come, like draw the structure of C3H6. So C3H6, first you have to calculate it in your mind. Okay, double plus 2 is there, C3H6 is there. So it is an alkane compound. And if it is an alkane compound, then what we have to do? We have to write it like this.
If it's not an alkane compound, we must write down like no, it is.
No, if the question will come that what compound is there, so we will learn the next compounds also. This is only one compound. We have to read 12 to 15 compounds. Okay, now write it down. Whole thing. This whole thing, now write it down.
Agatha, I guess you finished writing down half of it.
I just have to write saturated HC and unsaturated HC. And
And
then everything else. That's it.
Quickly write it down, guys, because if you will not get this, you will not get the rest of the chapter.
are you back? What have you written next to it?
Which part? Applied chemistry.
No, the right on the right of it. Is that names?
Yeah, names.
Okay.
Check, this is names. NAMES. Done? No? Okay, do it. I'm coming in 1 minute.
Does anyone know why Edric didn't come today for class?
He sent a message in the group. You can check that out.
Oh,
Okay, done, guys. Shall I do this? Shall we move forward?
I finished.
Aina? Okay. Now we'll come to the unsaturated hydrocarbon. Okay. Now, unsaturated hydrocarbon, okay, it is basically in a compound if one or more than one if one or more than one carbon and carbon bond are either double or triple, either double or triple, then it is called as unsaturated hydrocarbon. Are you getting my point? Are you getting my point? One, if only one is there, na, either double or triple. Double means carbon carbon should have double line, or carbon and carbon should have triple line. For example, we'll take one example, then you guys will get it more clearly. For example, if I will take one example, C, 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 C. Okay. Now in this we can see that, okay, that there is only single bond is there. Like if I will make these two lines, they are the saturated or unsaturated? Unsaturated hydrocarbon. They are called as unsaturated hydrocarbon. Yes, Agatha.
How about if there are 4 lines?
4 lines it cannot be. It can only has 1, 2, or 3 lines. Because if I will make 4 lines, for example, if I will make 4 lines, and I told you each carbon will have only 4 lines with them. So if I will talk about this carbon has 1, 2, 3, 4, 5 lines, which is impossible. Did you get it? Did you get my point, Agatha? This carbon has 5 lines, which is impossible because a carbon can exist only 4 lines. That is why. So for example, you can check this example, this one. Okay, it has triple bond between them. It is called as unsaturated hydrocarbon. Got it? Yes or no? Now, unsaturated hydrocarbons are of two types. It is of two types. The first one is called as double bond unsaturated hydrocarbon. Double bond unsaturated hydrocarbon. And the second one is triple bond unsaturated hydrocarbon. Triple bond. Double bond saturated hydrocarbon is called as alkene. It is called as alkene. Now we have to remember this word. Remember this word. Okay? Alkene. E-N-E. Yeah, I will write in all capital words. Okay, I will write it. A-L-K-E-N-E. Alkene. Okay? And this is called as alkyne. 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 This is called as alkene. This is called as alkyne. It is also called as olefins. 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 Now everyone please pay attention. Please pay attention. Don't write. I will give time to write. Please pay attention. Okay. Now for example, if I will write butene. What? Butene. Now this ENE is coming. This ENE coming means that in this compound, one carbon will have double bond with them. Like this. It is called as butene. Got it? Because En is coming. Okay. If I will say, everyone please pay attention. If I will say butane, butane. Now this Yn is coming in the last. It means that one carbon will have triple bond with them.
So, sir,
One
it's like
carbon will. Yes, yes.
so there is alkan, then alkene, then alkyne.
Yeah, alkane, alkyne, or alkene.
Alkane, alkene, or alkyne.
So if it is written butane, then what we have to write? Triple bond will be there. Okay. If double bond is there, then it is called as ene. If triple bond is there, it is called as ine. Now, everyone please pay attention. Agatha, right? Okay. If I will, the formula for that is CnH2n. Only double. Okay, CnH2n. And this formula is CnH2n minus 2, means double minus 2. Double minus 2. You're not able to see this? Huh? Maybe? What happened? Okay, this is double and this is double minus 2. For example, if I will tell you this formula C4H8, it is double, it is key. Everyone got it? Oh. Okay, it is double, it is called as alkene. If I will write C4H6, it is double minus 2, means 4 to the 8 minus 2, which is 6, it is alkyne. Got it, everyone? Yes or no?
Yes, sir.
Listen,
Got it,
David.
sir.
Okay, if it is double, it is alkene. It is not double,
Subtract
minus
if
2.
it is sub.
Double
Yeah.
minus 2, it is called as alkyne. Okay. For example, C4H8. We will make C4H8. So C4, and because it's alkene, so I will make double bond between them. Yes. Now, in the first carbon, how many lines should be there? 3 lines will be there. Did you understand? Ira, in the second carbon, how many lines are needed?
1.
Only 1, because it make 4. In the third carbon, again 1. In the last carbon, 3. And I will write H in it. 1, 2, 3, 4, 5, 6, 7, 8. It is 8 carbon, 8 hydrogen. Got it? Yes or no? Okay. Now if I will make this C4, 1, 2, 3, 4. Okay. And that one will have triple bond between them. So in the first carbon, how many hydrogen is needed? 1, 2, and 3. In the second carbon, how many is needed? No one is needed, because it's already 4. In the third carbon is already 4. In the fourth carbon, 3 more hydrogens are needed. It is become C4H6. Everyone got it? This concept? David?
Yes,
No.
sir. Yes, sir.
Okay, so everyone write it down this thing, and then we'll end this class. We'll continue with this tomorrow also. What happened, baby? What happened? Ishalaka anaka panaka chi. Ita palaka shita nikayo.
Sir, is there another, like, you gave another name for alkenes is olefins. Is there another word for alkynes?
No, it's not there.
Thank you, sir.
Everyone write it down. Then we'll end this class, and then tomorrow we'll read we'll continue with this. Yes, say we'll continue. Say we will continue with this.
Sir? Uh,
Sir, I finished writing. Is it okay if I leave class? We're gonna have guests in a few minutes.
Hello? Hello?
Yes, sir?
Yes, Ira was saying something.
Oh, no, sir. Tomorrow I won't be attending class, but I'll watch the video.
Okay. Even I guess it's probably Thursday also. I will be unable for this thing, for the class. So maybe Thursday, like most probably, it will be holiday. But I will confirm by night, today is night.
Sir, is it okay if I leave class now? I finished writing.
Yeah,
Because
you can leave.
Okay. Thank you, sir. Bye, sir.
Okay, bye. Nakapashi. Okay, guys, we'll end this class. I hope you enjoyed the class. Till then, bye. Have a nice day. Send your teacher care. And sayonara. Bye bye.